Dear children, topic for today is substitution reactions of alkyl halide. Myself, Dr. Digna Varghese. Substitution of halogen by cyano group. Here, the action of alcoholic potassium cyanide on alkyl halide to give alkyl cyanide. The formation of alkyl cyanides or alkane nitrites. Here you can see the reactant is alkyl halide and the reagent is alcoholic potassium cyanide. The reaction condition is high temperature and the product formed is alkyl cyanide or alkyl nitrile. Here you can see when an alkyl halide reacts with alcoholic potassium cyanide on heating, it will give alkane nitrile or alkyl cyanide and potassium halide. When alkyl halide reacts with alcoholic potassium cyanide, the alkyl halide eliminated and in place of halide ion, the cyanide ion substituted and forming alkane nitrile. Okay. So here in general, here you can see the general example. Here you can see bromoethane reacts with alcoholic potassium cyanide. On heating, it will give the bromide ion substituted by cyanide ion and forming propane nitrile or ethyl cyanide and potassium bromide. Here, three carbon atoms are here. So, the main carbon chain is propane. Here, nitrile group is attached to this. So, it is propane nitrile or we can say that ethyl cyanide. Substitution of halogen by isocyanide group, that is NC group. The alkyl halide reacts with alcoholic silver cyanide to form alkyl isocyanide. You can see here the nitrogen atom is joined to the carbon atom. If it is a cyanide group, alkyl part is joined to carbon part of cyanide group. Here we can see the nitrogen atom is attached to the carbon part. So it is isocyanide plus silver halide. This is a general representation. When alkyl halide reacts with alcoholic silver cyanide on heating give alkyl isocyanide and silver halide. Here you can see the silver halide is eliminated. So here you can see methyl iodide reacts with alcoholic silver cyanide to form methyl isocyanide, that is methyl carbyl amine and silver iodide. Okay, reaction is also known as the formation of isocyanide or alkyl carbyl amine. Okay, so the substitution of halide group by isocyanide group or by the action of alcoholic silver cyanide forming corresponding isocyanates or carbyl amine. Next reaction is the substitution of halogen by NITRITO group. Here you can see the alkyl halide reacts with potassium nitrate, that is alcoholic solution of potassium nitrite and forming alkyl nitrites. Alkyl nitrites. Here you can see the alkyl halide reacts with potassium nitrate in alcoholic medium. The halide group is substituted by nitrite group. That is, here the oxygen atom is attached to the carbon part. So it is nitrite. Alkyl nitrite. So another example is when ethyl bromide reacts with alcoholic potassium nitrite. Here the bromide is substituted by the nitrite part, ONO, that is ethyl nitrite is formed and potassium bromide is eliminated. Okay. Substitution of halogen by nitro group. Here you can see an alkyl halide reacts with alcoholic silver nitrite solution and forming a nitroalkanes. So it's a formation of nitroalkanes. When alkyl halides are heated with silver nitrite, alcoholic silver nitrate, nitroalkanes are obtained. Here you can see methyl iodide reacts with alcoholic silver nitrite. Silver iodide eliminated in place of iodine, that is substituted by nitro groups and forming nitromethane. So it's a formation of nitroalkane by the action of alcoholic silver nitrate or alkyl halide. Another reaction is the substitution of halogen by carboxylate group. We know the carboxylate group is COO minus. Here you can see the carboxylate group, that is silver salt of a fatty acid reacts with alkyl halide in, that is in alcoholic medium. Here you can see an ester is formed by the elimination of silver halide. When silver salt of fatty acid in alcoholic solution reacts with alkyl halide, by the elimination of silver halide, it will form ester. Okay. Here you can see silver acetate reacts with ethyl bromide. Alcoholic solution of silver acetate reacts with ethyl bromide. By the elimination of silver bromide, it forms ethyl ethanoate, that is ethyl acetate. Okay, here you can see ethyl acetate. So, substitution of halogen by carboxylic group. Another reaction is substitution of halogen by alkynyl group. Here you can see alkyl halide reacts with sodium alkynide. Alkynide means a triple bonded carbon attached to sodium. So it is a sodium alkynide. Okay. It will give alkyne plus sodium halide. A higher alkane is obtained here. Instead of sodium here, or sodium is replaced by alkyl part. So a higher alkyne is obtained. We know alkane is single bonded carbon compound and alkene is double bonded carbon compound. Alkyne is triply bonded carbon compounds. Here you can see methyl iodide reacts with sodium alkynide. Sodium iodide is eliminated here and forming propyne. 1, 2, 3 carbon atoms. So it is propyne. Propyne is formed. Here acetylide. Acetylide is converted into higher alkyne, that is propyne, by this simple reaction. Another reaction is substitution of halogen by amino group. Here you can see an alkyl halide reacts with ammonia, that is NH3. It is splitted in this way for better understanding. Here you can see an HX is eliminated and forming RNH2, that is primary amine. Next, it reacts with one more halide, alkyl halide. It will also eliminate one of this hydrogen atom and halogen atom from here and forming minus HX and forming a secondary amine, that is R2NH. It forms a primary amine here, it forms a secondary amine here, and it will further react with an alkyl halide because there is one more hydrogen. And minus HX is removed and forming a tertiary amine. Okay. It will further react with one more alkyl halide and forming a quaternary ammonium salt, that is R4N plus X minus. Okay, so it is a quaternary salt. Here you can see an example, that is methyl bromide reacts with ammonia in alcohol under pressure and temperature. It will eliminate hydrogen bromide and forming methyl amine, that is a primary amine, that will again undergo reaction with methyl bromide minus hydrogen bromide and forming a secondary amine, dimethyl amine. It will further react with one more methyl bromide by the elimination of HBr, forming tertiary amine, that is trimethyl amine. It will again react with methyl bromide and forming quaternary ammonium salt, that is tetramethyl ammonium bromide. Okay. Substitution of chlorine or bromine by iodine. Here you can see an alkyl halide reacts with potassium iodide. Here substitution of chlorine by iodine and forming alkyl iodide by the elimination of potassium chloride here. It's a general representation. Here you can see an example. Methyl chloride reacts with potassium iodide. In methanolic solution, it will form methyl iodide and potassium chloride. Here you can see the iodine substituted the chloride ion here and forming methyl iodide. So substitution of chlorine by iodine takes place. Here you can see an alkyl bromide reacts with potassium iodide, alcoholic solution of potassium iodide, forming alkyl iodide plus potassium bromide. Methyl bromide reacts with potassium iodide in methanolic solution. It will form methyl iodide and potassium bromide. Here you can see the substitution of bromide ion by bromide by iodine. Okay, and forming methyl iodide. Here you can see the summary of the reactions, that is when alkyl halide reacts with alcoholic potassium nitrite, it will give alkyl nitrites. Alkyl halide reacts with alcoholic silver cyanide, it will give alkyl isocyanide. Alkyl halide reacts with alcoholic potassium cyanide. It will give alkyl cyanides. Alkyl halide reacts with methanolic potassium iodide. It will give alkyl iodide. Alkyl halide on treated with amine. It will give quaternary ammonium salts. Alkyl halide on treated with sodium alkynides. It will give alkynes, higher alkynes. Alkyl halides on treated with alcoholic solution of silver carboxylate will give ester. When alkyl halide treated with the alcoholic silver nitrate, it will give nitroalkanes. So these are the reactions in this video. So please study. Thank you for your attention.